Okay. So I do not use Blackboard. So if you went to Blackboard, there's nothing there. Because I hate having to have a site that you have to log into and you lose access to. So everything that I'm going to be doing, all my videos, all my notes, and everything else will all be posted on my website. It's easy to remember. It's bakersmathclass.com. So you go to that website. This is what's going to show up. You click on Calc 1, and you will see the information for Calc 1. So the only post up there right now for you guys is the first day of class. If you scroll back, these are every other time that I've taught Calc 1. So not only do you actually have access to all the recordings that I've done for you guys, you technically have recordings of every time that I've taught this lesson for calculus since like the beginning of time. Because I've been using this website since 2012. So there's a lot up there. Including all the notes, including sample tests and stuff I've done. Those will change a little bit different because we're using ALEKS this year. But same basic concepts that'll be on there. I am here actually every single day now. So I'm actually the new math teacher for the middle colleges here. So I'm actually in the building every Monday through Friday from 7 o'clock in the morning until 2 o'clock in the afternoon. On Tuesdays and Thursdays, I'm here till your class. So you can email message me. We can find times to help out if you want extra help. I will be available from Tuesday and Thursday from 2:30 to 5 in my room, which is E206, which is right over there. So if you absolutely do want to come in before a test or before things because you need extra help, feel free to do that. I do know they have some tutors that can help down with Calc 1 and stuff in the tutoring center, but I know they get backed up and everything else too. And I'm trying to be as flexible and easy as I can be with people being able to get help. All right, so let's go over the syllabus a little bit. So basic conversation. There's my phone number. That's my cell number. So text me, call me. You call me, it's probably going to go to voicemail because I don't know who you are. But you can easily text me. I've responded to texts while I'm sitting at hockey games, baseball games. If I can actually answer the question, I'm going to answer it. So the fastest and easiest way to get a hold of me is to text me. You need access to ALEKS. Do not buy ALEKS from ALEKS. Get it through the bookstore or something because it's actually cheaper. We got a special rate because technically this is a beta test of the ALEKS calculus program. They have not technically released this. Me and Ms. Smolkentine are actually testing this. So, and then next year they'll actually be expanding into Calc 2 and whatnot. So if you're going into Calc 2, odds are you'll probably be doing it again. So, all right. Basic grading, 40% of the modules in ALEKS. There is 5 modules. One's the prereqs, chapters 2, 3, 4, and 5. Each one's basically 10%. There's 3 tests, 10% each. Your final exam is 20%, and participation is 10%. Participation is not, I'm not taking attendance when you come to class. Okay? Honestly, everybody gets that 10% unless I basically see you only showing up for the tests. And that's where I ding that. So as long as you're coming on a regular basis and I see your face every so often, you're going to get the 10%. If for some reason you can't come to class, let me know. Like, I'm recording everything on Google Meet so you can watch it afterwards, but you also could technically join the Google Meet. If for some reason you can't get here because you're stuck at home sick or whatever else, but you want to come to class, just email me. I'll send you the link so you actually can listen in live in the class. One of the great things that came out of COVID, if there was anything that great that came out of COVID, is the ability to have multiple ways to access a class period or a class. So I have access to all of those. Here's your course outline. This is basically what we're going to be covering. Your first test is going to be on the 16th, and that's on chapter 2. Yes, it comes up quick. Next test on October 16th. Here's the syllabus. We will not have class on Veterans Day. You will have a test on the 13th after Veterans Day, and our final exam is on December 9th. We got the early final exam. Yes, so we don't have to wait till the last day. So, any questions on that? Awesome. Last page is your class code for ALEKS. and the financial aid access code. This will, if you do not have your code for ALEKS yet, this will give you 2 weeks to get that code. So you put it in today, and you basically have until the 11th to get your code for ALEKS. So if you haven't gotten to the bookstore yet, or you haven't gotten financial aid, or whatever happens to be, this code will get you in so you can start working immediately in ALEKS. All right. If you go to try to get into ALEKS, because I know not everybody has their computer with them to try it right now, if you're working on it and you get stuck, take a picture of what's on your screen and text it to me, so I know what's going on and I can try to help you get in. It's typically pretty easy. If you've done pre-calculus, odds are you've probably done ALEKS already here. So you have an account. You do not need to make a new account. You just add this class to that account. All right. Any questions with any of that before I actually go to ALEKS and show you ALEKS for those of you who have not seen it before? All right. Yes, I'm still here. All right. When you log into ALEKS, this is what you're going to see. You have to go through all this. I get to skip things. So the first thing I'm going to have you do is go through a tools tutorial, basically to show you how and to put the things into ALEKS. So how to make lines and whatnot there. Really simple. And then it's going to give you your initial knowledge check. When you take this initial test, set aside like an hour and a half to 2 hours. Take your time with it. Do not cheat. Okay? All the cheating is going to do is put you to something that you might have no idea how to actually do. All right? So the one thing that I really, truly like about ALEKS, and I know a lot of people don't like it about ALEKS, but no, that's not what I truly like about ALEKS. What I truly like about ALEKS is that it is going to give you the ability to practice things that you need practice on. So I will tell you right now, the number one mistake that any of my students make in any of my calculus classes that I've taken is algebra skills. Forgetting how to factor, forgetting how to do some of the simple trig functions, forgetting how to deal with square roots. Like, there's certain things that you did in pre-calculus and other classes that you just don't remember how to do or make mistakes doing. Not the calculus. The calculus, believe it or not, actually is not that bad, and it's not that hard to do. It's those soft skills, it's those algebra skills that people make mistakes on. So actually, there's 239 topics total. 105 of those are prerequisite skills. You should test out of the vast majority of them. And some of those skills are as simple as adding and subtracting signed decimals. Not complicated topics. But it's there for you to practice. That prerequisite module, you should test out of the vast majority of those 105, which means you have like 200 or 125 topics left to go in the calculus class. That's what I'm saying. It's not a ton of topics. All right. I know in my pre-calc class, I have like 400 something topics. So 100 and something actual calculus concepts is not that bad. There are no more topics that are like problem type 1, problem type 2, problem type 7, things like that. Those were annoying and a waste of time. I totally agree with that. They got rid of that stuff in calculus. So you do not have those type of problems. All right. So when you're going through the knowledge check, really try, practice things. Like I say, don't look stuff up. If you get it wrong, you get it wrong. All right. It just means you might have to do a little bit of practice on it to get through. I've got the module set up that it will push you through. So the prerequisite module will be already locked. You will only have to do topics that you need for the actual skills that we're going to be doing. Okay. So that's basically how that works. So here's the knowledge check, which I'm going to skip through real quick. You can see, I don't want to show, no, that's not what I wanted to do. I don't want to see that. You can see how it's different. It's designed for calculus. So there's a lot of information being in there. And you might have no clue how to do this. Just say, I don't know. That's a totally valid way to do the question. Like derivatives. You don't know derivatives. You probably don't even know what that symbol looks like. I'm trying to find one that actually would make sense for finding derivatives. You still don't know derivatives. Factor by grouping. You might know how to do this. So you could actually do this and put in the answer. I'm now going to skip the rest of the knowledge check so you can see how this works. Oh boy, I sucked. That's okay, because that was what I attempted to do. So once you've done the knowledge check, this will show you what your topics are here. Notice I got 35 topics mastered on the knowledge check. There's 239 total topics left. I click start my path. So when you go up in here, you'll see this is chapter 2. That's what we're starting to work on. Okay. In chapter 2, there's a bunch of topics. Here's all the topics that are up here. You'll notice a lot say algebra and pre-calculus. Those are prerequisite topics. The limits and derivatives, that's the calculus topics. So these are things that you need to practice on. The ones with the diamonds, those are goals. Those are the ones actually in chapter 2. So if they're open, work on those. Eventually, you're going to get to one with a little lock. That means you can't work on it until you've done one of the other topics. Okay? That's it. Nothing crazy. It is designed to give you practice. Okay? You need... Every time, the first question always is an example. Don't just skip it. It's there for a reason. It literally will help you understand what they're expecting you to do for that problem. Read through it. Oh, okay, that's what they want me to do. And then start the topic. I know way too many kids, especially like when I was doing this high school, would just go, yep, start. And then the first question, oh, I don't know what I'm doing. I need help. That's what this is for. Okay? Once you do it, there's 5 points. You get 3 questions right, you're done with the topic. You get questions wrong, you have to do more problems. It's designed to make you practice. Okay? It's designed to help you understand that topic before it moves on to the next one. All right? Any questions with Alex? Yes.
We have to pay for it.
Yes. I think it's $60. It's cheaper than buying the actual calculus textbook, which is like $250. So that's good. The other thing on here, you have your assignments. The only assignments that you're going to see in here are the test reviews. So you can click on Chapter 2 test review. This is basically exactly what your test is going to be. So there's 15 questions. You can practice this as many times as you want before the actual test. I'm going to pull problems just like this. And we're going to print it out because we don't have computer lab to do it in class. But you can practice it a million times before you go take the test. Doing this does not do your module or your pie piece stuff. So even if you get all these right, it's not going to solve your problem with the module. You still have to do those topics. The grades won't be in here. I actually probably will put the grades in Blackboard just because it's easier to put them there for you to see them. So I will probably update the grade book in Blackboard, at least by the first test. All right. Any questions with that? Okay. Let's start working.
I have one question.
Sure.
Maybe we'll be getting but the syllabus itself when we're mentioned signs on weather sign.
Oh, did I leave that in there?
So that is
No, it's an Alex. Oh, okay. Yeah, I forgot. A line I forgot to delete when I edited it. No problem. I'm like, wait, where was it? All right. So let's do some work.
actually I do have one quick question.
Good.
We need a calculator for this class to start one.
You do not need a certain calculator. Honestly, I'll allow you to use Desmos for most of it. So if you have Desmos on your phone, you can use your laptop. That's fine. It actually has a graphic calculator, everything else built into the program too. So, but honestly, I use Desmos for everything. There is no need for you to go out and spend $100 on a TI calculator that costs the exact same as when I went to school and does the exact same thing. So it is the only piece of technology that does not depreciate in value. All right. Who in here knows what a limit is? Oh, great. Your pre-calc class didn't get to that. All right. What's the answer if you plugged in 0? Okay. What do you get? So you get 0 on the bottom. What do you get on the top? Okay. So you also get 0. All right. So where does this graph go as you get closer to 0? So let's graph it. Hold on. I'm going to type it, then I'll switch over. Because otherwise, I won't be able to see. All right. So here's my graph. Nice problem. As I get closer and closer to 0, at 0, it doesn't exist, right? We figured that out. But it does seem to go through a point, right? Okay. So what a limit does is a limit allows us to get closer and closer to a point without actually hitting that point. So we want to see what's happening on both sides of the equation as we get closer and closer to that point. So here's the first thing Alex asks you to do. It gives you these, and I want you to fill in the blanks. So on this side, if we plugged in -1 to this equation, you'd get 1. If you plugged in -0.5, you'd get 1.75. This is where Desmos really makes your life nice. So if we go back to Desmos, and there's a little gear that's right up here. If you click that gear, a little table icon opens up. You can now type in any values you want, and it'll give you the answer. So -1, -0.5, -0.1, and then we can keep adding points. So on this table, you do not have to sit there and type all the numbers in one at a time. Use the feature of the calculator to do the table to make your life a little bit easier. Okay. Now, on the other side, so we've done this side, it wants 0.001, 0.1, 0.5, and 1. So if we look here, the answer is 3.003001. And it wants to round it to 4 decimal places, so it would be 0.0030. Then we have 3.31, 4.75, and 7. Any questions on how I got any of those numbers? Yes.
How do you access the table again?
So there's a little gear at the top. No problem. All right, so we've got these numbers. I filled them in on the table. What do you notice is happening as you get closer and closer to 0?
It's close to 3.
The number's getting closer to 3, right? So what the limit as x goes to 0 says is what's happening on both sides of the equation as we're getting closer and closer to that point. So in this case, they're both getting closer and closer to 3. And if we put in numbers that were even closer to 3, I mean, closer to 0, like if I started adding a bunch of zeros here on both sides, we get even closer to 3. And eventually, it'll just tell me it's 3. Okay? But it gets closer and closer to 3 the closer and closer we get. So my limit for this problem, as x goes to 0, is 3. That's what a limit means. A limit means looking at going from both sides. What is that number getting closer and closer and closer to? Yes, I want another one. Your turn. So, and all these questions that I'm pulling are right from the topics you guys are going to have to do in ALEKS. Okay, so they literally look exactly like this. So when you go home and do it, you're going to know how to do these problems. Which means when you do your initial knowledge check, you might already have a leg up on doing some of these problems because you know how to do them. All right. Find me the limit for this one. Okay, what do we get for 5.95?
2.2715.
Okay. What do we get for 5.999?
2.2504.
Okay. And if we plug in 6, we get undefined. So what do you think the limit is? Yeah. I go with 2.25. That seems a reasonable estimate for it. They've also, for those that are totally stressed out about ALEKS, been a little more flexible in these answers. So what they've claimed to do is for these questions, there's a range of values. So like if you put 2.250 like 1 or something like that, it probably would mark that correct as fine. So it's, but 2.25 I would say would probably be the exact right answer for this one. Everybody understand why? We good with that? Okay. I'm happy with that. So in this problem here, my limit 2.25. Good. What's the limit right here?
Or does the limit have to go to both sides?
What was the one key thing I said about limits? They have to go from both sides. So up there, this limit doesn't exist because there is no way to go from the other direction. So that's where that square root at the top would be a negative value, so that doesn't exist. We will talk about how we can do those problems in a little bit too. Actually, we'll talk about that now. All right, let's look at a graph. What kind of function is that? Is it a function? We'll start with that question.
Yes.
Yes, it is a function. What's the definition of a function? Correct. So in this case, there are places where 2 points exist on the same vertical line, but one doesn't exist and one does, like at 2 and at -2. So in those situations, we're fine. So this is a function. It is a piecewise function. You're correct. So piecewise functions are ones that have multiple parts. All right. So let's look at the limit from x goes to -2. There's a little symbol next to it. So remember we were talking about how the limit has to exist going from both directions? So there are some situations where we want to look at just going from one direction. And that's what these little symbols mean. So that is coming from the left. And that is coming from right. So that minus is when I'm looking at it going this direction, the -2. So when I'm going in that direction, here's my highlighter color. It's too hard to see. When I'm going in that direction on the graph, what is the value at -2? What would be the limit at -2? Yes. So one of the biggest mistakes people make when they're doing limits is they will put the x value instead of the y value. When we're looking at these, we're always looking for the y value. So in this case, that's 0. All right. Now, if we're coming from the right, what's the value at, not you. What's the limit as we go to -2 from the right? It's 4. Because we're basically coming up to that point right there, right? That point doesn't exist. Okay, that's fine. In limits, what point would be there? In that case, that's 4. So in that case, it's 4. Actually, let me put a little line through that so it doesn't look like I'm circling it. All right. So the limit coming from the left is 0. The limit coming from the right is 4. What is the whole limit? Doesn't exist. For it to exist, it's got to go to the same place. Even though the left and right both go to somewhere, like the last one I was looking at, the left one didn't go anywhere, the right did. In this case, they both go somewhere, but they don't go to the same place. So in that case, the limit does not exist. Everything I'm doing on the board is saved, even on a slideshow. So like if I go on and you want me to go back, just ask me and I can switch back to the slide. That's not what I wanted. All right, so the limit. All right, find me those three. All right, what's the limit as x goes to 3 from the left?
Zero.
What's the limit as x goes to 3 from the right? 0. So what's the limit of x goes to 3? It is 0. Okay, make sense? Good. What's the limit as h of x goes to -1 from the left?
Negative.
Okay. Negative infinity, a valid answer. Yes. Okay, so you're going, so this is a great example of what the types of questions I ask. I will ask questions of people even if they have the right answer sometimes. Do not assume you're wrong. Okay? What I'm going for is I want you to figure out, like, I want to get some information on why you thought that. Okay? So never, ever assume you're wrong if I ask you why. Everybody always, why? And then they hesitate and they change their answer. Don't do that. Give me a reason why you said it. Like, I really, because that's what helps me be able to explain back to you, like, if you had a misunderstanding or you might have gotten it right completely for the wrong way. Like, there's certain ones that you look at, like, okay, I have no idea, but this sounds right. And you might get right, but you don't understand why. So this way I can explain those types of things. And there's a lot of people who aren't talking and they might have no idea how you got things. So understanding that is very helpful. So negative infinity, good. And negative infinity is a completely valid answer, so is positive infinity. All right, what about from the right? Negative infinity, yes. I know going from the right's hard because you're so used to reading graphs from left to right. Going the other direction is hard. All right, so as h of x goes to -1. It is negative infinity. That is a valid answer for that. It does not that it doesn't exist, it goes to negative infinity. What's the solution to h of x at -1? It's -1. There's a point right there. So the other thing that is important to realize is that the limit doesn't necessarily have to equal the value. That only occurs in piecewise functions. Okay? So since I have a value that exists there at -1, there is a value when you plug in -1 to the function. However, that's not where the limit goes. That can happen. But again, only in piecewise functions. A typical polynomial or typical function will not have that situation happen. All right. Sorry, I wasn't meaning to shake. I was meaning to erase. Let's do this one first. I don't want you to graph it, which I know would have been the first thing you'd have thought to do. I want you to think about what's happening when you're plugging in the number. Okay. So let's look at 3. Okay, let's go from the left first. So if I'm plugging in a number that's from the left of 3, what's the top going to be? Positive or negative?
Negative.
It's going to be negative because it's a negative x, right? And remember, we're not talking about unplugging in -5. Like, we want to get numbers that are close to 3. So if I'm picking numbers that are closer and closer to 3, the top's going to stay negative, right? Okay. So the top's negative. What about the bottom? As I'm getting closer and closer to 3, is the bottom positive or negative?
Negative.
It's going to be negative on the left side, when I'm looking from the left side, right? Because that means that number is going to be smaller than 3, and any number smaller than 3 minus 3 is going to give me a negative answer. Okay. So that means my final answer would be what? It'd be positive. Everybody understand my reasoning there? No. It's not giving me my limit, though. What's happening? So what's happening with the number on the bottom? As I get closer and closer to 3, is that number on the bottom getting bigger or smaller? It's getting smaller, right? It's getting smaller and smaller. Okay, so when I'm taking a fraction and I'm dividing by a smaller and smaller number, what happens to the overall number? It's getting bigger, right? If I divide something by 0.1, if I say 1 divided by 0.1, that's 10. If I divide 1 by 0.01, it's smaller, it'd be 100. That number's getting bigger and bigger, right? So as I get closer and closer to 3, what's that number going to?
Positive.
Going positive, and it's going to infinity. So in that case, this is going to positive infinity. So yes, you could have graphed that, saw it instantly, done. And honestly, I would suspect when you do this for homework, that's exactly what you're going to do. What I wanted to do, though, is I wanted you to start thinking about how the functions work and how the equations work. Because what happens a lot of times is when you plug things into a calculator or a computer or now AI and everything else, it makes mistakes, especially AI. Okay? The calculator, garbage in, garbage out. You screw something up putting it in, you're going to get something wrong out. AI, you don't know. You could ask it the exact right question and it could give you the wrong answer. Okay? It's getting better. Totally not there yet. I should know I'm testing the AIs in math. So it's like, it still makes a lot of mistakes. So what I want you to be able to do is when you get an answer, see if that makes sense. Okay? Like this one, it's like, okay, I have a general idea. I know the answer is going to be positive. So if my graph goes down, something's wrong. Like that's where you start to catch mistakes and start to like really understand what you're doing. Okay, so sometimes when I'm explaining things, I'm not expecting you to do this at home. I know you're not going to, but it's good to have that understanding behind the scenes to be able to figure out like what mistakes could be. Okay. All right. What about the right side? What's the top of the equation going to be? Top's still going to be negative because they're all positive in that case. What's the bottom going to be? The bottom's going to be positive. So that means my answer is going to be negative, right? The bottom's still getting smaller as I'm getting closer and closer to 3. Well, if I do 3.1 minus 3, that's 0.1, right? 3.01 minus 3, so it's still getting smaller. So it's still going to infinity. It's just going to negative. So what's the limit overall? Does it exist? Not exist? Goes to infinity, negative infinity? Doesn't exist. One's going to positive, one's going to negative. Even though they're both infinity, two different infinities. So this limit does not exist. All right. Do this one. All right, what do we got? What's the limit as I'm going from to 2 from the left? Top positive or negative?
Negative.
Top negative. What's the bottom? It's going to be positive, right? Because 4 is bigger than whatever's going to be over there. So positive. And the bottom's getting really, really small, right? The nice thing about these problems are same concept. The bottom's going to get small. So this is going to negative infinity. All right, what about coming from the right?
Positive.
So top's still negative. Now this is going to be bigger, so the bottom's negative. So it's going to positive. Positive infinity. So that means the overall limit does not exist. Yeah. All right. Anybody in here extremely well? Okay. Then I'm going to blow your mind on what you can do with Desmos. Okay, there's 2 Desmoses. There's the graphing calculator and there's the scientific calculator. Graphing calculator, amazing. You can graph things all you want. It actually will do derivatives and integration and everything else in there. Scientific calculator has another amazing feature. It allows you to put in equations. So what's this equation? Yeah. Yep. What do we typically call it? Slope. Okay. Y2 minus Y1 over X2 minus X1, right? Okay. What I set up here was all I need to do is put in the numbers for X. It will calculate the Y's and then find me my slope. It does it all for me. I will copy and paste it into the notes so you can see how I set this up. And you'll see why in a second. All right. Does anybody know what calculus actually does? Like, what's the actual purpose? What is the one thing you think you're going to learn in Calc 1? Yeah. That's actually Calc 2. That's integration. So what's a derivative? So the derivative actually is telling me instantaneous slope. So you might have actually done a problem that looks like this at one point in pre-calc. Yes, delete that. I want a new slide. There you go. You might have done a problem that looks like this. Maybe. Or you were plugging things in when you were doing composite functions and stuff like that, plugging things into the problems. That's known as the difference quotient. Oh, it's frozen. Okay, awesome thing. Actually, it's not frozen. I just forgot to switch slides. So for some reason, that comes, just tell me. Because that means I'm working there and projecting it to there, so I don't always catch it. So that's the difference quotient. So if you look at it, that's in essence slope. It's y2 minus y1 over the change in x, which is what h is in this case. That's what I'm changing the x for. So what derivatives do and what calculus does is it allows us to find the slope at any given moment. Why is that important? why would I want to know the change, how the instantaneous change of something? Why isn't average just enough? Yeah.
You look at them,
Okay. This is where calculus basically becomes rocket science. All right. This is literally why they call this type of stuff rocket science, is because it was designed to figure out the motion of rockets and projectiles. So as a rocket's going up, it has certain forces on it. I need to know the forces on that are acting on it instantly. And it changes constantly. So I can't just take two measurements apart and go, okay, find the average, because those 2 points might be after the peak and the average is 0. It's not going to be helpful. Okay. The only time that it's actually 0 was at the peak. Every other point would be different. So if I could figure that out, that's helpful. They actually had used that in the stock market to be able to predict stock market changes. If you can look at how it's actually changing, you can start to anticipate and project how things are going to happen in the future based on how things are changing in the present. So derivatives, which is what we're going to really get into when we're starting to look at the end of chapter in chapter 3, really asks us to figure out how fast those things are changing in a way that's easy to do. Chapter 2 is all limits. So we're going to do this the hard way first. I'm going to show you what, because we really want to understand the meaning behind it, stuff like that. And then we'll do the easy way. So here's the actual problem that we're going to do. So we want to find the slope of a tangent line. So what's a tangent line? Yeah.
Running through.
There's one mistake you made in your statement. Through it. What does through it mean?
I was thinking visually.
Yeah, so there's two different types of lines. We have secant line and tangent lines. Okay. This is N. There we go. That's a secant line. Secant line goes through that point. The difference between a secant line and a tangent line is a tangent line just touches the graph at that exact point. Okay. So that tangent line right there would tell me the slope at that point. Because for it to be a tangent line, it's got to touch it and not actually go through. That means it would have the same slope. It would be basically parallel at that point, right? And if you remember back to geometry, parallel lines have the same slope. Okay. So let's take, this is why I was showing you that wonderful little thing, because what it wants you to do so we cannot find the slope of a line at a single point, because to find a slope, you need one. We need 2 points. So in essence, we can never find the slope of a tangent line. We can find the slope of secant lines. And if those secant lines get closer and closer together, what can we now do that we now know how to do? If those two lines, if the bottom number is getting really, really small, because that x1 minus x2 is getting small, and that's going to get to 0, which I can't divide by 0. So what can I use now to find what's happening at that exact point? limits. That's what limits come into play. Limits allow us to find the slope at 0, which we could not do otherwise. So here's the problem. It would be extremely annoying for you to do this out by hand, because you would have to plug in all those values, then plug it all into the slope equation. So this is why I created this. So the first point they gave you is 1, -4. So on the graph, on this, my first point, I'm plugging in 1 for x1. That's the first point. The second point is going to change. The second point are going to be all those numbers they're telling you there. So the first number is 0.8. So here, I'm going to put 0.8. And down here, it gives me my slope. So in this case, my slope is 5. The next one says 0.9. So I change that to 0.9. Now my slope changed. The only thing you're going to have to set up differently is this right here will be whatever equation they give you in the problem. So we're looking at 4 over x. And the nice thing about Desmos is all you have to do to put the number underneath is type the number next to it. It'll automatically put it underneath for the letter. So you don't have to do anything special. So I literally typed x3 and it put the number down. So it's really not that hard to actually be able to do that part. So now we have 4.44. I would have you guys actually do this, but I know not everybody has Desmos set up or anything else right now. 9. 9. So as I go to 9.999, I'm getting closer and closer to 4, right? All right, let's try the other side. If I plug in 1, I get undefined. So let's do 1.1. 36, 01, 396, 3966, 3999. So it's getting closer and closer to what? We're down the bottom. Positive 4. It's getting closer and closer to 4. Let's try it. There we go. So there, the red's my original graph. That's my point right there. And the green line is my tangent line. Slope is 4. And it touches right at that point. Doesn't go through anywhere else. So we can use our limits to be able to figure out tangent lines. That makes sense? All right.
Did you pull up the scientific calculator?
The scientific calculator? If you're going on the web, it's just desmos.com/scientific.
Oh, so it's different.
Yeah, and I really hate the fact that if you're using the app, it's actually 2 apps. But as crazy as that, the app and the website are exactly the same. So you literally can go to the web, like on your Chrome browser or Safari or whatever else on your phone, and go to the Desmos. It will look identical to the app. There's nothing different. So I wouldn't actually install the app. I would just use the website. Yeah. So if you go to Apples, here's all that you have access to for Desmos now. The 3D calculator is actually really cool. So if you actually ever get to Calc 3, you can do 3D graphing now in Desmos, which is amazing. All right. So since I know you've got a ton of stuff to do on Alex, you have to take the initial test and start working through some topics. We're going to be done today. I will have all these notes posted tomorrow morning along with the video, so you'll have access to it all. If you happen to text me this weekend to get help, I'm at the Renaissance Fair in Lebanon for like the next 8 weeks. So just if I don't get back to you immediately, it's probably because I'm talking to somebody. So, but feel free to text me and I'll get back to you as soon as I can. All right. Any other questions?
Are the notes gonna be on Blackboard or your?
On my website. Everything will be on my website. The only thing I'm going to put in Blackboard will be your grades.